In section 5, we're going to get a little bit technical, a number of rules to look at, and we'll use our PowerPoint slides to help us. Negative exponents and scientific notation. Now, when we look at negative exponents, let's take a look at what we had reviewed earlier. X to the fourth divided by x to the sixth. Well, we then said that this equals x to the fourth, and we take the exponent from our denominator. As it crosses the division bar, it changes its sign. So we end up with x to the negative 2, which is a negative exponent. And again, we're qualifying it by saying x cannot equal 0. But what does x to the negative 2 mean? Well, if we go over here and write out what we have, we use exponents as a shorthand to indicate we have 4 of the same factors. In our denominator, we have 6 of the same factors that we're now going to cancel out as if they were ones. So this is a 1, this is a 1, this is a 1, this is a 1. So what is left on top? Well, just a 1 over 2x's in our denominator, which is 1 over x to the second. Or another way to look at that, leave the 1 up there, because there's a 1 in front of every number. Bring this down. This becomes a negative 4. So this will be 1 over x to the second. So what does x to the negative 2 equal? Well, it equals 1 over x to the second. So in a sense, this is over 1. Bringing this exponent down to the denominator changes its sign. We think of this a little bit as if it is the inverse. This is this, and its inverse in changing the sign is this. Okay, let's go on. So this is the rule. And in a sense, this is over 1. But then, keeping in mind there's a 1 up there, bringing this down to the denominator, the sign of the exponent changes, and in a sense, it's inverse. So, rather than work out a lot of these, I've left them worked out for you. We just want to follow it. We will be doing our own working out as we do our practice. So again, this is over 1, and there's a 1 up there that we keep. Bringing this down to the denominator, it becomes this, and simplifying, 3 to the second is 9. And x to the negative 7, bringing that down. Now here they're giving us a helpful hint. What is the base here? The base is only the x. not the 2. So the 2 stays in the numerator, and just the x to the 4th goes down. And when it crosses that division bar, it changes its sign. Again, what is the base? Only the x. So in a sense, you can think of a 1 out there. This goes down, changes its sign, but the -1 stays up there, and we say the place to put the negative sign is by the fraction bar. And in this case, the same. This is the base. This is what goes down, and we simplify. And in this case, the base is a -3, and there's a 1 there in a sense. So this goes down like so. That is squared. And that becomes, of course, -3 times -3 is a positive 9. So note the difference between these two. You have to realize what is the base. Now, if we find a negative exponent in the denominator, again, just moving it up changes its sign, and every number is over 1. We don't write the 1. Now, for something like this, where this is negative in the numerator, negative in the denominator, just move that up and move that down, and this is what you get. Now, if anytime you want to pause to read these rules in more detail, just do so. All right, now this is again a summary of rules of the exponents, but I'll move it down. These are things we've done already and serve as a good background for any dealings with exponents. If you'd like to copy this in your notes, again, just pause it, and through copying and viewing and studying, again, many of these you know already. So again, we just did that one, so we don't have to do that one again. Okay, now they're giving us this example to work, and I left part of it, but I took out all this work here so that you can actually do it along with me if you want to copy it down. So first off, we said that if this were a fraction like so, and it was raised to a power, then the numerator is raised to that power, and the denominator is raised to that power. So that's where we are. So we'll make a division bar here, and we're going to do the top. Now, an interesting note, when it's like this, these negative exponents act just as if they were regular numbers, and the rules of multiplication apply. So this is going to be 3. -2 times -2 is a positive 4. So we're just using the rule of raising a power to a power, which we multiply. This then becomes a to the negative 6. This becomes b, remember there's a 1 there, to the negative 2. Okay, we're going to do the same thing to the denominator. This becomes 3, and negative 4 times negative 2 is a positive 8. And this becomes a to the negative 14. As I multiply the 7 times negative 2, and this becomes b to the 6th. Now what we want to do is simplify in here. We want positive exponents. So over here I'm going to bring this 4 down, subtract it from the 8, and I get 3 to the 4th right there. So I'm taking this, as it crosses the division bar, it becomes like a negative 4. I want my exponents to be positive, so I'm going to bring this a to the negative 14 up, and up here becomes a positive 14. So this gives me a to the 8th. Moving this across the division bar, the sign of the exponent changes, and I do that addition. And then here, again, I want positive exponents, so I'm going to bring this down. Here it becomes a positive 2, and this gives me b to the 8th. Now, notice I've left this in its exponential form. This should be simplified. 3 to the 4th is 81, and there is the answer. So the protocol for doing it, put this by each of the items here, the numerator, the denominator, do the multiplication, do the simplification, and there's your answer. Okay, we're now going into what is called scientific notation. There we get to see it, scientific notation. There is a protocol for doing it. Here it is written out. What I will do for you is to review all these steps for you as we go on. If you want to pause and read this over, fine. So what they said is if you have a number like 4700, there is a decimal point right there. Step 1 is you want to put this number to make it a number between 1 and 10. And we do so by moving the decimal point 1, 2, 3 places. We now get the number 4.7, and then we multiply it by some power of 10. And how many decimal places did we move it? And we moved it to the left 3 places. So it becomes 10 to the 3rd. And there is your answer in scientific notation. Now, if we have a small number like this, again, we want to move the decimal to make it a number between 1 and 10. So I'm going to move it to the right 1, 2, 3, 4 decimal places. I now get the number 4.7, again, times 10. And how many places did I move it to the right? 4. Now moving it to the right makes it a negative exponent. And there it is in scientific notation. You'll have some practice with this on your mini lecture booklet. And here's a little summary of what we just did. So big numbers are going to be positive exponents. Small numbers with lots of zeros and it's really tiny are going to be negative exponents. And you're moving it right or left depending on the size of the original number. Oop. Okay, so they want us to convert this now. So let's take a look at it. So we're moving it 3 places. So it's just 1, 2, 3. There's our number in standard notation. Now here we have the number 6.54, but it's going to be a small number because of the negative exponent. How many places do I have to move the decimal point? 5 places. Well, there's 1 already right there, so I have to add 4 zeros. 1, 2, 3, 4. So now when I move it 5 places, 1, 2, 3, 4, 5, there is my number. And I usually add a 0 to fix the decimal place. And that's basically the rule. Now, when we are multiplying, let me raise this up here so you can see it a little better. Operations with scientific notation, we just use the rules that we've just had. And let's check it out. And we can move it down again now. So here we have in parentheses this scientific notation times in parentheses this scientific notation. So what we do here is we multiply this times this, which is what they're showing, and we get this. We then multiply this by this, and since we're multiplying powers of 10, we just add the exponents. A negative 2 and a positive 5 gives us a 3. Now this is not in scientific notation, by the way. If it was, you'd have to move, if you wanted it, you'd move this over 1 place, and this would become 5.913 times, you moved it 1 place over, so you have to add 1 there, 10 to the 4th. But all they're asking is to put it in standard notation. So suppose we work from here. How many decimal places do we have to move it to? 4. So we have 5 and 913. We have to add 1 0. We add the 0 there, that's okay. So moving it over, 1, 2, 3, 4, there's our answer. There's our answer. Now, since this wasn't in scientific notation, we only had to move this one over 3 places in this form, which from where the decimal was, we just had to add the 0. So it works either way, depending what they're asking you. And for this last one, we have 4 goes into there 0.3 times, this one. And then we just move this up. This becomes then a -9. So that's to the -5. How many decimal places do we have to move this? Well, 5 places. So this again is not in scientific notation. So we have 1 0 there. We have to add 4 more. 1, 2, 3, 4. And there's our decimal. Now you'll be practicing this as we do our booklet and your practice and quiz me. So while it's still fresh in your mind, we'll pause the tape and you can work number 1, these 4 parts. Well, this is going to be 1 over 3 to the second, 1 over 9. Now the only base here is a, so 8 stays in the numerator, and it's a to the third. For something like this, we just switch them around. Y to the third, x to the fourth. This goes up, changes the sign, this goes down. Now here, this is just a little tricky. This becomes 1 over x to the second, which is 1 over 16. Anything to the 0 power is 1, but I'm going to write this one as 16 over 16. Why? Because I have to add them. And this then becomes 17 over 16. Okay, let's go on to the next part. We'll pause it, and there's a lot of stuff going on here. So let's start to simplify a little bit here. This is going to be a to the -9, this part. And remember there's a 1 there. So this becomes a to the -1, which is a to the -10, which then becomes 1 over a to the 10th. Now there may be other ways to do this, but that's the way I did it. Okay, here to get rid of this, this is going to become 2 to the third and x to the 12th, x to the 15th. So I need positive exponents, so I have 2 to the third is going to be 8. And then I'm going to bring this 12 down, and I get that. Okay, now I'm just going to multiply here, and I'm going to get x to the 4th, y to the -16. So when I write the answer to this, it's going to be x to the 4th over y to the 16th. So I have to keep this positive. Now notice our numbers here. Negative divided by a negative, that's going to become a positive. So we don't have to worry about the sign anymore. And 12 and 6, that becomes a 1/2. This becomes a 1/2. Then I'm going to keep these positive. So I'm going to bring the 2 down, and this becomes x to the third. I'm going to bring this up, and that becomes y to the positive 3 up there. As I bring this negative 6 up, it becomes a positive 6, and that should be my answer. And looking at the answer below, I see they have taken that away. Again, you don't need to write the 1. So that's what they have. And they have that funny diagonal line there. All right, going on to letter E. Well, again, I don't have a lot of room to work, but let's see what we have here. When I do this multiplication, this is going to become m to the 8th here, positive 8. So up in the top, I'm going to have m to the 10th as I add my 8 and 2. And on the bottom, I get m to the negative 10. So as I bring this up to the top, for letter E, I'm just going to get m to the 20th. And I'm going to clear it so I have a little more room here. Okay. Now, for something like this, we had said earlier a technique was if you have a fraction that is to a negative power, a workaround would be to take the reciprocal of this, and that becomes its positive power. So let's do that. So what I did is I took the reciprocal of this, just flipped it, and now my exponent is 3. And that might be a little convenient. Now you could do it the other way too. So this is going to be 2 to the third, right there, x to the 12th, y to the 21st, over 3 to the third, x to the third, y to the 15th. And now you just simplify. So this is going to be 2 to the third is 8. This is 27. I want my exponents to be positive. So this goes up. I subtract it from 12. I get x to the 9th, y to the 6th, 15 from 21. And again, you want to be neat. You want to be able to read this carefully. And again, when you writing your test out and your final exam, if it is neat and orderly, I can look at this and give maybe partial credit. But it is tedious and lots of challenging things. Now, when we get to letter G, something easy if you could recognize it. Anything to the 0 power is 1. So the answer to G is 1. You don't have to concern yourself with all of this, as long as it's the base to the 0 power. Okay, so a couple of things going on in letter H now. Negative times a negative will give you a positive 10. And we're going to put these right where they should go. This is going to be r to the negative 3. Well, there's no r's there. So this just goes down to the denominator. S Negative 2 goes down to the denominator. Now it's t to the first times t to the negative 4. 1 minus 4 is a negative 3, so our t goes down as a 3. And that is the answer to letter H. Now, when you finish, of course, you could put the 10 in the middle. All right, let's go on and we'll move it up a little bit as we go into our scientific notation. Again, we'll give you some time. We want to put these in scientific notation. So we're going to move the decimal 1, 2, 3, 4. 8.3 times 10 to the 4th. 3, 6, 1.25 times 10 to the 6th, 3, 6. Now these are going to be negative exponents. And we're going to move it 1, 2, 3, 4, 1, negative 4. We're moving it over 1, 2, 3, 4 places. And here we're going to move it 1, 2, 3, 4, 5, 6. Negative 6, 6.89. Now we're going to convert. Again, hopefully we give you time. But how many places do we have to move the decimal? Well, we have to move it 6. So there's 2. Moving it over 2, so how many zeros do I need to add? 4. 1, 2, 3, 4. And there is my answer. Now this is a negative 5 here. So I have 8, 7. The decimal point is there. How many decimal places do I need to make this a small number? Well, I got to move it 5 places. So there's 1. How many zeros do I need to add? 4. 1, 2, 3, 4. And fix the 0. All right, here I have to add 10 places. There's 3. So there's 3, and I had to move it 10 places. So how many zeros? 7. 1, 2, 3, 4, 5, 6, 7. You want to put commas in there? In MathLab, you don't have to put the commas. Okay, so I have 202. There's 1 decimal place. How many more zeros do I need to add? Well, 1 place, so 2 zeros. And then an extra to fix the 0. Now here, I'm going to multiply 6 times 9 is 54. And this is 5 and a negative 9. So that's going to be 54 times 10 to the negative 4 power. So we're going to put this, I guess, in regular notation. That's how we did it in our PowerPoint slides. So the decimal's there. How many places do we need to move the decimal? 4. So we add 2 zeros. And our number then should be 0.0054. And that looks good. Now here, 5 goes into 15 3 times, times 10. This then goes up, becomes a positive 2. So that's to the 5th. The decimal point is there. How many zeros do we need to add? 5. So we can move this 5 decimal places. 1, 2, 3, 4, 5. And there's our answer. Okay, well, hopefully, this was useful and helpful and gives you some practice as you develop your mastery skills.